Welcome to DevOps for Defense. Today we're going to do something a little bit different. This is simply going to be an online demonstration, and we're going to dive into something that we often state is the #1 leading indicator of high-performing teams. That is configuration management. So when we think about configuration management, I like to point back to the State of DevOps report and the research and analysis associated with that looks at high-performing teams and the characteristics and attributes of high-performing teams. And what we see is configuration management, version control in particular, is the =1 leading indicator of those high-performing teams. And what we want to be able to do is to take those practices that have been identified as critical enablers and bring those into our environment. Our challenge is #1 to understand it, and then #2 to tailor it to our context appropriately. So let's dive into a quick overview and then a demonstration of what this actually looks like in practice. So we'll start with some simplified definitions. Change management is a great place to start. This is a process in which we actively determine content that's going to be delivered by our teams and our systems through releases. We often create a lot of complexity around change management, and what we see in the research is that lightweight change management processes are most effective. And so we want something in place that allows us to certainly understand and manage the content of our releases, but we want it to not be so onerous and costly that it becomes a problem for our teams or an impediment to capability delivery. Second is version control. This is, when I say configuration management, this is the paramount, most important part in my mind. This is ensuring that we know what our baseline is at all times with rigorous tracking and a repository. And we want to know, who did what to the baseline when they did it. Best case, why did they do it? A tie back to the change management. And what evidence do we have that that change was done correctly in accordance with expectations? Did we actually accomplish what we wanted? Next, trunk-based development is a very popular practice. In the purest sense, it is a practice where we will only make small, frequent changes to a baseline in a main branch, directly into that main branch. And then we'll continuously integrate that such that we have confidence that we can deliver capability from that main branch at any time. What becomes challenging here is you have to implement the corollary. If you ever do make a breaking change into that main branch, sometimes referred to as trunk, sometimes referred to as master, then the most important thing for any team is to ensure that if they make a breaking change, their top priority is always to immediately either revoke or correct that change. So it puts a lot of onus on your quality assurance measures to know that a change you make was in fact a good change and didn't create undesirable outcomes. Now, I've marked this one as red. We're not going to demonstrate trunk-based development in its purest form. Instead, what we're going to look at is a practice known as GitHub Flow. GitHub Flow really takes advantage of what's a capability called a pull request that's provided by centralized repository managers. So what this practice does, it augments trunk-based development. You want the same principle of small, rapid change to your baseline, but the way you implement that is by creating a small, short-lived branch where your changes are made, and then you submit a pull request to merge that into the main branch. And that supports visibility. It supports things like peer review of the change. It gives you the opportunity to integrate continuous integration in a controlled way, such that you can maintain clear objective evidence within your repository of exactly what's going on as that baseline evolves. It gives you a little bit more, quote, safety as you work through your process. So we will demonstrate that. And then a few practices that I think are valuable. A feature toggle, simply a switch that turns on or off a particular behavior. And the way you employ this most effectively is as you create some new behavior, you know that it's probably not going to be perfect right out of the gate. So you want to disable that behavior initially as it's maturing within your baseline, as you're building up, the appropriate and necessary test and quality infrastructure that gives you confidence in that behavior. And so you want to be able to disable that as you roll out your changes to your baseline. But you want to do it in a way that doesn't create the merge hell that we talked about earlier. So a simple way to do this is to create a toggle. We'll look at that and enable, disable based on a flag, a configuration, something like that. Branch by abstraction is a little bit more complex of a strategy. What it allows you to do is simply replace a given set of behavior more by the practice of dependency insertion or inversion of dependency, if you prefer, such that you can not impact the interfaces to the rest of your baseline as you change a specific behavioral aspect. And then finally, versioned interfaces. This is something we're not going to be able to take a look at because I'm not going to build a real interface. But put simply, as our systems evolve, our interfaces often evolve as well. And that creates integration challenges, especially with users of our systems, external in particular. So we can either, create hard alignment of delivery schedules across our entire user base or system community, or we can deliver backwards compatibility. And that's what version interfaces do, is give us a mechanism to provide backwards compatibility of our APIs or interfaces, such that as we evolve the system, we do it in non-breaking ways. It's a really interesting topic. There's great information out on the web for version interfaces, but we're not going to be able to go into that in depth here. So our fundamental premise, we just recognize that branches are evil. And I say especially when misused and abused. And the challenge is we often prefer, seemingly, to misuse and abuse branches. The branches need to be kept very short in their lifespan because they fundamentally defer integration. Anytime that I'm making changes that sit to the side, that don't actually come into the baseline that I trust and deliver, I'm not integrating. And what happens is over time, as we snowball series of changes into that baseline, the ability to bring them into that main baseline that we would deliver from becomes harder and harder. And that results in what's often referred to as merge hell. That's something that nobody wants. It takes a long time. It's incredibly complex and error prone. And our job is to deliver with confidence. So techniques that drive errors certainly should be avoided. Now, the corollary that becomes challenging here is great. I have this branch that I'm working out of. I'm doing small changes, but I made a release. And so I've got some deployed capability that users are out there taking advantage of. So I need to create a branch for that release so that I can maintain it. And that's not a bad strategy. It's certainly better than not having a clear understanding of the delivered baseline. The problem with that is the more and more you do it, the more difficult and complex it becomes to actually maintain it. So once you've got 2, 3, 4, 5 different release branches that are actively in use in different contexts and settings, the cost of maintaining them just skyrockets. So we want to be cautious. We want to be very deliberate in how we make changes or how we proliferate the number of baselines that have to be actively maintained at any given time. The strategies that we're going to go through here show how we can try to keep our changes to as few branches as possible without doing breaking changes to any release. In fact, continuing to be able to release from the same branch over time. to the greatest extent possible. So we're going to do a demonstration here. This is a listing of what you'll need if you wanted to replicate. I am using really good quality tools. I'm using them largely because they're free and because they make a lot of this very easy in my experience. There are certainly other tools out there, tools that I love and I use in other contexts. I'm not trying to prescribe any tool, but I just want you to recognize the kinds of things that you're going to need to implement the absolute fundamentals of good configuration management, and what alternatives you might have. One thing that I will highlight: automated test. In my demo, I'm just going to keep it very simple and do unit testing. In any reasonable system that you would build and develop, you need to include some kind of automated acceptance testing. And there are all kinds of solutions for that. I'm not going to go into that in as much depth as I would really like, but be aware that that's something that's absolutely foundational to being able to deliver with confidence. So here we are. These are the tools I'm going to use. Feel free to choose the right tools for you and your environment. And let's take a look at the script that we're going to go through. I've broken it up kind of into a 3-act play. So I'm going to create this little toy application that gives us something to work from. And all it's going to do is generate some numbers from a distribution, and then it's going to aggregate those into some single value that we can report. In our case, just print to the command line. So how are we going to go about that? Well, the first thing we have to do is get things set up. We're going to create a repository, initialize everything, get our continuous integration in place, and make sure that we can release. So that's, it's going to start off very hello world-ish, but we're getting the foundations in place that we need to implement good configuration management. Next, we're going to actually build some features and get a release out. So we're going to start by just doing some basic, initial work. We're going to release that because we want to make sure that we're tracking things, but we're not going to change the fundamental behavior of the application. Then we're going to create our MVP for the real capability, which is publish or report an aggregated numerical value. That'll get us to our version 1 capability. And then we will advance that a little bit. We're just going to change the way that we aggregate numbers. We'll release version 2. It does have an impact on the interface and the expectations of output. So we've made that a new major version using the rules of semantic version. And then we'll go into Act 3. Oh my goodness, we find a critical bug. What are we going to do? How do we update the current release, and how do we update the past release? Now, I do want to note, this is a practice that we see often in our world, maintaining these multiple releases. It's not necessarily the best way to go about it, but because it is such a common thing, I wanted to take some moment here and show you how that can work. So with that said, let's dive into the demonstration aspect. So let's dive into our demo. Act 1 starts with the initialization and setup. We're going to create a repository, initialize our application baseline, create continuous integration, and then make a release process. So let's dive right in. Step 1 here is create myself a repository. I'm going to keep this very simple. CM demo. We'll keep it private. We'll add some basic files, README file. I'm going to do a Gradle gitignore template, and I'm going to create a license, an MIT license. And we'll just create that repository. There we have it. I've got my repository established. First thing we want to do is change management. So let's come over here and create a few tasks for us. I want to init my app. I want to create a continuous integration pipeline. And I want to create a release pipeline. So when we get those three things done, we will claim success on Act 1. And we will go ahead and get started immediately. So the first thing I'm going to do is clone my URL, or copy it rather, and then I'm going to come into my local machine. I have a directory where I keep my repositories. And the first thing I want to do is git clone, simply pass in that URL. Now, that's created a new directory called cmdemo, the name of our repository. And if I take a look at the contents, we'll see that it has those three files that were initialized when we created the repo. So that's exactly what we want. The next step to actually do the work we've defined is initialize the application. So for now, well, I'll tell you what, let's go ahead and follow our GitHub Flow practices. So I want to make a branch. I'll do my small targeted changes in a branch, and then I'll submit it as a pull request. So let's make a little branch. We're going to say git branch. We'll call it init app. We'll switch to that branch. Git checkout, init app. And we can see now here in our command line, we've changed our location or the branch that we're working off of to init app, and we're ready to get started. We can also check this with the git branch command. But let's get to work. So we're using Gradle to support our build, perform that automation. So let's just go ahead and initialize using Gradle. Gradle init. It's going to ask us a few questions. We're going to make an application. We're going to do it in Java. It's going to be a single application project. We'll use Groovy. We'll use the latest JUnit test framework. CMDemo is a fine name, and we'll follow convention. So org.devops for defense. CMDemo. And there we have it. We've done everything we needed. And just to test things out, I can run a build. And you can see our build was successful. Let's see what it is we built. Let's just run it real quick. You can see now we have a hello world application initialized in this branch of our repository. So in terms of objectives of our first task, we can claim successful initialization of an application baseline. And let's go ahead and finish this off in our CM environment. So the first thing we need to do is stage the change. So git add, and then we'll commit it. Git commit, we'll add a message, and we'll start our message with the ID of the issue that we're working. Git initialize an application. Outstanding, and now let's push that up to the repository manager. Git push origin and our branch name. Init app. There we have it, and we're done. So we come back to GitHub and we can see here's our original commit, or when we initialize the repository itself, and I can now create a pull request. So let's take a look at that. I'm going to pull my changes that I made in my init app branch and merge them into main. That's a fine comment. So we'll create the pull request. We can see that there are no conflicts, and it's telling us that no continuous integration has been set up. So this is the best we can do with what we've got right now. So we're going to go ahead and accept that. I can go through and look at the individual commits. For example, I can do look at the files that have changed. I can review those, comment on them. Working with the team, this is a great way to peer review changes. But again, the real trick is make sure that your changes remain small as you work through the process. So let's go ahead and merge that, and we'll confirm our merge. Outstanding. We've merged our pull request into main, and now normally I would delete this branch. It doesn't do me any good having it hang out, but for the purposes of the demo and some visualization that I want to show a little bit later, we'll let this thing hang out. Deleting the branch does not delete the history or the changes. It's all present in main. It just cleans things up for you when you look at your history. So there we have it. We've completed number one. When I come in here, because I did have my issue ID'd in my comment, it's automatically linked it along with the pull request. So very good. I'm happy with that. I'm done. So let's go ahead and close issue number one. And we've now made some progress. Outstanding. What's next? The second thing I want to do is remember item number 2 on our issues list was to establish a CI process. Here we are, create a CI pipeline. So I'm going to use GitHub Actions for that. I'm just going to use the Gradle template that comes built in. This is going to create a file in our .github file within a workflows directory called gradle.yaml. And all it's going to do is establish a Linux environment. It's going to set up Java for me, and then it's going to run my Gradle build. As long as Gradle build passes, which includes compile and unit tests right now, then my changes will be deemed good. So this one, to keep it simple, I'm just going to commit straight to main. Added my CI, going to commit my new file, and we'll be able to see the difference when we look at our graphics for our history. And there we have it. Now I go back to my base. I have GitHub workflows. That's where my pipelines are defined. My app folder, this is where my application is. Gradle wrappers, my build control, and then a series of files that help support that execution, along with my basic README. So we're making good progress. Let's go back to my issues. Finish my CI. I'm going to go ahead and take credit for that, close it out. And we're off to the races. Now, what's interesting, because I pushed that into main, it actually ran continuous integration for me. So I can go back in my repo and I can see exactly what happened. It ran through a series of steps. You can see that we set up and ran Gradle. We did our compilation, established our classes, we packaged everything up into jars, ran a series of distribution scripts, assembled, we did our test data, ran our tests, ran some basic checks, and everything was successful. Then it simply cleans itself up, returns the resources to the system, and I'm good to go. So that's what our continuous integration is going to look like as we make changes from this point forward. Okay, now our next activity to close out Act 1 is to create a release pipeline. So to create a release pipeline, let's come back down here. Remember that we're in our init app branch. We want to get back into main. So let's say git checkout main. There we go. We switch back to main. And let's make sure that we have all the latest changes from our origin. So git fetch will pull down the history and information about the branches. And then git pull will make sure that all my files are updated to the latest. So there we have it. Outstanding. In order to do this next step, to create a release pipeline, the way I'm going to do that is through a code editor. I'm just going to use VS Code. Here you can see we've pulled our content in. I can open up my app folder. I can see the build file that's come in. I'm going to make a few tweaks just so things work well as we go forward. I'm going to set that up to be a Java application right now. And I have my .github workflows folder. So here we're going to just create a new file. We're going to call it release.yaml. And I have already built this a couple of times. So let me just steal shamelessly from a previous file and paste that in. So what is this going to do? The first thing it's going to do, we're going to call it our manually triggered release. And the manual trigger will be a dispatch that we run by clicking a button. It's going to ask for two inputs. What's my semantic version number? And it's going to ask for a short description of the release. Now, when we get down into the jobs, you're going to notice it looks very similar to what we saw before. It's going to check out our code, set up Java, run Gradle. So we're going to repeat the work that we do in our standard configuration, continuous integration process, but then we're going to actually create the release. We're going to name the release using our semantic versioning identifier. And once we have that, we're going to upload our assets into the release. So in this case, let's just double check and make sure we see our distribution. And we can see that our distribution is in fact named app.zip. We want to name that cmdemo.zip when we push it out, and we can see that that's going to happen now. So that is our change. We now have defined a release. That's exactly what our change management system asked us to do. So the only thing left to do is to actually get this under configuration managed control. And so here we can see that I've got that change. I've made it. I've actually failed to create a branch. We'll let it slide this time, but I'm working in main. So let's just go ahead and commit this change into main. First, stage it. Identify our issue number. Added my release pipeline. All right, and now time to push it. Okay, great. We can come up here. I won't be creating a pull request this time. I actually pushed my change directly into main. If I'm doing trunk-based development, this is exactly what it looks like. We'll try to remember to employ our best practices and do GitHub Flow going forward. Now here we've seen that it's automatically kicked off a continuous integration build for us when we made that commit, and we can dive in and check its status as it's working. Here we can see it's already done its setup. It's already set up Java. It's running the Gradle build right now. We have now completed successfully that Gradle build. All looks well with the world, and we've got our green checkbox. Continuous integration is good to go. So to wrap up this and prove to ourselves that our new release process works, let's actually go take a look at that, and let's run it. So I'm going to take the changes that we have in branch main. I'm going to give it a semantic version number called 0.1.0, and we'll test our initial release workflow. And to start all this, all I do is click Run Workflow. That's now dispatched an event into the system. The system has picked it up, and it's triggered the workflow defined in that YAML file that we just added. So let's go check on this thing. We can we can see its definition if we want, but let's just check its status. So just like before, when we did our CI, we've set everything up, got our Java in place, and now we're running our Gradle build. So we're repeating that process, making sure that the quality is good before we actually establish the release. Here we can see that's completed. All right, we did create the release. We have uploaded our assets into that release, and then we've done our cleanup. And we've seen our indicator go green. So our first release should now be in place. Let's go take a look. And sure enough, there we have a release. I can click on it, CM demo, exactly as I would have expected. And it also zipped up all the associated source code for that. So I've got the artifacts in an easy to consume package ready to go, everything associated with that release. The other important thing to note is it did tag my repository. So I have a tag now, 0.0.1, which is based off of my release ID, the semantic version of my release ID. So there we have it. That is Act 1 complete. So we have now gone up to this point. We forgot to make a branch there. That was my fault, but I think you got the idea. And we've got our version 0.1.0 in place, and we're ready to move on to Act 2. Act 2, we're going to have some coding involved. So buckle up. This is going to be certainly more fun for me. I know it's not fun to watch someone code, so I'll probably take some editing license and spare you from some of the gory bits as we work through it. So here we are. We're back in our repository. Just to finish off, release pipeline is working, so let's go ahead and close that, take credit for it. And our backlog is empty. So let's make a couple of issues to keep tab of the work that we have planned for Act 2. So the first thing we want to do for our toy application, we're going to just generate some numbers. And once we have numbers generated, I want to make an aggregator. And it's just going to take the numbers we generate and condense them down into a single value that we can report. And let's say that I want to start creating a minimum viable product here, something that works, certainly meets the requirements that I have as I understand them right now, but allows me to test my understanding. And then finally, I'm going to go ahead and create an advanced aggregator because I'm confident I'm going to learn something. I want to make a change based on that MVP. Okay, so let's take a look at our issues. We have issues 5, 6, and 7 now ready to start work. So let's dive right in and create a number generator. Get status is going to just check us against the rest of the system, and we can see that we're up to date and good to go. So let's get started. Again, we'll try to use our good practice of GitHub Flow. Create ourselves a branch, call it numgen, and we'll check that branch out. So now we're working within the numgen branch, all is well, and we're ready to actually build some code, move away from hello world. To do that, let's just start by taking a look at hello world. And here we have it. All this is doing is, yes, I like Java. All this is doing is asking us, or is saying run a greeting, and that greeting is hello world. Now, VS Code just did something somewhat annoying. It's worth mentioning. let me show you what it did. Go to my repos, go to CM demo. It just created a folder called .vs code. So what are we going to do with that? Well, it's not something that we want in our repository. So in order to prevent that from kind of polluting our environment, I'm going to add a couple of paths to my git ignore. And now anything that happens, the VS code drops in, it may actually drop in a dot settings as well. So we'll go ahead and capture that too. So now hopefully the any mess that shows up from my editor will be ignored whenever I go to incorporate that back into the repository. Okay, so good little tip there. Let's see, my job is to create a number generator. I'm going to do that as an independent class. So first thing I want to do, we'll just call it number generator.java. And what I'm going to start off now is I'm actually going to pull some code from the previous time I worked through this, spare you guys some of that and fast forward. But I will come back and show you how it's set up and working. Okay, so we've put some code in place. We've put a test in place. It's going to create an instance of our number generator. It's going to generate some numbers and two assertions. It shouldn't return a null value and it should return at least one value in my list. So there we go. As long as I can do those two things, then I think my number generator is working correctly. And so this is what that number generator looks like. It's actually using normal distribution from Apache Math. And I just created a normal distribution around 50 with a standard deviation of 2. And I'm going to sample that. I'm going to sample it 100 times, and I'm going to return a list of 100 samples. So very simple, nothing fancy or complex there. And then I did update my, actually, let me steal this import. So I update my application. And all my application is going to do is give me a number generator, generate some numbers, and then tell me how many numbers were generated. So that's my new application. I've officially moved away from Hello World. So let's save that. Now, one critical thing that I have to do, I'm going to cheat just a little bit, pulling some content over, is I have a new dependency. That dependency is seen here. It's the normal distribution from Apache Commons Math. And so I've got to find a way to make sure that that goes into my project. And the way I'm going to do that is I'm going to add it to my dependencies in Gradle. And this is going to be an implementation dependency. And I'm just going to use the latest version from, in this case, JCenter. So we're going to pull Apache Commons, Commons Math, and version 3.6.1. So we can see, here's another instance of the semantic versioning that's being used by our dependencies. All right, that's I'm going to update my configuration. And that gives me all of the stuff I need. So now the moment of truth. Let's see if it works. So let's just clean everything up. And let's run our build. Oh, I see the problem. Let's go to app test. So I'm just going to take out the test for Hello World because that is not a thing anymore. I'm going to leave the framework for app tests. Maybe we'll come back later and use that, but we've completely changed the behavior, so that's no longer valid. So great, we found an issue right out of the gate. Gradle clean, Gradle build. Outstanding. We successfully completed our build. And we now should see different behavior when we actually run it. And certainly we do. Generated 100 numbers. This is exactly what we want. This issue is now resolved. We just have to finish it off and claim success. So to do that, as before, we're going to stage our changes. We're going to make our commit. I have forgotten our issue number. It's number 5. So for issue number 5, we've got our number generator now in place. And git push origin numgen. We're going to push that branch up. Outstanding. And let's come back to our base repo. So our change is in place. It's not yet in our main branch. Let's go to create a pull request. There we have it. We've linked to the issue number. It's gone in and looked for any conflicts. There are no merge conflicts to be worked, so we're good to go there. And as we saw earlier, we're going to work through that continuous integration process. But this time it's actually running our new tests that we've defined for that new behavior, which is exactly what we want. While this is running, we can come take a quick look at its status. We're about halfway through that process. All looks well. There's my tasks running off, and we were successful. Outstanding. We should get our green check. We do indeed. And so let's go back here. All is well. Let's check our pull requests and claim success. So that is done. I need to undo that. I need to reopen. Okay, we need to merge our pull request, confirm our merge. Now it is done. So we'll close that thing off. Outstanding. And of course, we want to go take credit for that work. We're done. Close that issue. Great. We have our number generator. We're halfway through to something that looks like our minimum viable product. Our next step would be to work issue number 6 to create a number aggregator MVP. So how do we do that? First thing I want to do is get back to my main branch. So git checkout main. And let's make sure we're all up to date. Do a quick fetch. And do a pull. Make sure we've got all the latest in our main branch. Now we've got everything we need. And we're going to start working that MVP. So let's call it ag MVP. Let's jump onto that branch real quick. All right, we've got everything there. We should be good to go. We're working in the ag MVP. And we're simply going to, just like we did before, close that out. I'm going to follow the same pattern. I'm going to create a class for aggregating our numbers. Like here, I'm going to create a test, and I'll come back as soon as that's done. Okay, our aggregator is now in place. We'll start with the test. All we're going to do, well, let's probably start with the behavior. Our MVP behavior just said, hey, I've got some list of numbers. I need to turn them into a single value. So all we're going to do is loop through those values. We're going to sum them up, and then we're going to return the sum of those values. And we built a test that makes sure that we're seeing that actual behavior. So we'll create an instance of our number aggregator. we'll create a list of numbers and we'll know what's in those numbers. We're just going to create 10 numbers that are multiples of pi, and we're going to add them to our list. And as we add them to the list, we're going to sum them as we go. So we have an expected value, which will be our sum. We'll run our function, we'll get our results, and then we will make sure that our expected value, or sum, is the same as our result. So there's our behavior test. We'll have everything that we need. And we've updated the application itself such that after we generate our numbers, we create an aggregator. We're gonna pass those numbers into the aggregator, and we'll get some value out and then present that to the screen. So save everything. Our build environment did not change for this. No extra dependencies or anything. As you can see, very simple. So let's go ahead and do our first test. Git clean. No, not git. Gradle clean. Gradle build. Outstanding. And let's just run it, run our application and make sure everything looks good. Outstanding. So we've got 100 numbers centered around 50, and we've summed them. So we got something pretty close to 5,000. That's exactly what we've expected. Our work here is done. Our MVP has been established. So let's go take a look at that. You know, one thing I do want to perhaps go back on. You know, we created a release 1.0. If you recall, our script had a release, 0.1. Our script had a release 0.2, and that 0.2 release had our number aggregator. Now, I haven't actually committed any changes for this work that we're doing, so there's nothing that prevents me from coming in here very easily, pulling straight from main, 0.2.0. And I can actually release just my number generation. We've already seen the workflow complete for continuous integration on this one. We're simply going to do this, repeat that process, and then create the release associated with it. So while that's running, let's go ahead and work through our process. We've done our tests locally. Let's get our work submitted up and take credit for it. To do that, we're again going to git add, git commit. Let's make sure we have the right issue ID. This is number 6. So for issue number 6, we added some sum aggregation. And let's go ahead and push it. So git push origin ag MVP. And we're done. Okay, back to business. We can now see that while we were doing that, release 0.2.0 has been published, and my ag MVP branch has now shown up, and I can create a pull request for that. So I'm good with that title. Create that pull request. It automatically checks for merge conflicts. No problems there. And you can see our continuous integration has kicked off. I can wait a few seconds for that to complete. Make sure that it's what I want. I can even watch it run again if I choose. Okay, CI passed. I've got my green check. All is well with the world. Come back to my pull request. I'm happy with that. So let's merge our pull request, confirm the merge, and we're good. Now, I'll say it again. I would normally delete the branch. For visual purposes, we'll just leave that open here. All right, so we're good. Let's take credit for our work. Number aggregator MVP is done. We'll close that. And now Act 2 has only one item left. But you know what? This is a useful product for the toy problem that we've established, so it's worthy of release. So let's run our workflow. We're going to pull off a main, and we have now achieved the big day. Version 1.0 actually generates and aggregates numbers. So we'll run that workflow. You can see that it's being triggered. The system has picked it up, and in just a little bit of time, come back to our main view, and we should see our release update very shortly. So great, we've got the robots off working to create and deliver our release and the artifacts associated with that. We have got a little bit of feedback, let's say, from that release. And the feedback is, hey, you know, doing a sum is all well and good, but I need an advanced aggregator. I really want the mean of the numbers and not the sum of the numbers. So how do we do that? How do we do that in kind of a smart way that employs some of these best practices? Well, just like before, let's see if we got our version 1 published, and we did. So just like before, let's see, we're working on number 7. We're going to come back down here. We're going to get started on that work. Let's go back to main. And let's just make sure that we're all up to date. So we got get fetch. You can see it pulling the tags in from our releases. And we'll do a get pull. So now we have all of the updates in our main branch. And let's just create a new branch to do this change. So get branch, and let's call it ag mean. And now we're in our ag mean working branch for this issue. So here's a place where we have a working product. It does what is advertised. It creates a list of numbers, and it aggregates those numbers to a single value. Mission accomplished. It's released. Maybe there are people in the world who are using it, and we're about to introduce what is a pretty substantial behavioral change. So we need to think about, you know, our strategy for how we run at that change that would not back us into any corners. So how are we going to do that? I already have a number aggregator. What I'm going to do is a little bit of refactoring. I'm going to show you the branch by abstraction approach, and hopefully you'll find it useful and interesting, something that you can apply to future work. As a part of that, we're going to introduce a feature toggle. And once again, I hope that you'll find that feature toggle useful and valuable as well. So let me go off, let me work on some code, and I'll be back shortly. Okay, I think we've got the code in place and ready to go. So what have we done? First, we knew we wanted to create as minimally a disruptive change. We wanted a feature toggle so that we don't break functionality that exists. So what I've done is used a strategy called branching by abstraction. It allows me to very simply maintain different behaviors within my code base that I can turn on and off with a toggle. So I took my number aggregator and I changed it from an actual class that implements behavior. I turned it into an interface. Now, by doing that, the API remains valid. So my number aggregator and how I use it doesn't actually change, but I can toggle the behavior that I want. And so I've taken our sum and I've just moved it into a new class called number aggregator sum. It's the exact same code as we had before for release 1.0. But I've also added, there's a couple of tweaks we need to make. So we need to make sure that we're actually implementing that interface in our class. There's my sum, here's my mean. Sorry for the coding. We'll create that mean, and in this time, we'll still do the sum, but then we'll divide by the number of elements within the list and return that to the calling class. So there we have it. Number aggregator sum and number aggregator mean are in place. Of course, we have preserved the test for sum, and we have established a new test for the behavior we want with mean. Very much the same. It's just taking a set of known values and then dividing them by the count and making sure that we get a mean back. So I haven't tested this yet. We may find some issues, but that's the basic strategy. Now let's take a look at the feature toggle. So what does that look like? Well, what I've done is I've just created some values. Now these are obviously in code, so I have a very strict control. They'll be locked in by the compiler. But I created two strategy values. One is sum and one is mean. And then I created a toggle. And that toggle references one of the strategies that I established there. And then down in the behavior, whenever I'm creating my number aggregator, I check the value of that toggle. And if it's sum, then I'm going to use my sum behavioral class. And if it's mean, I'll use my mean behavioral class. The rest of the code honestly doesn't know. It's just going to aggregate like it did before, and it's going to put out its value. That part of the behavior is unchanged, but now I can toggle it back and forth to meet my needs. So there's all the changes, no changes to the build. By adding the tests, they're automatically incorporated into the build, no issues there. So moment of truth. Let's clean everything up, make sure we're on a good slate. And see if we can get a build working. Oh, our build failed. Oh, I have a stray character. Looks like there. So let's see if we fixed it. All right, we got our bugs fixed, and now we have a working build. Our tests have passed. Let's just run it and see if we have different behavior. And sure enough, we've generated 100 numbers, but now instead of the sum of those numbers, we're getting the mean of those numbers. So we've pretty much implemented exactly what we want. We've sort of changed the behavior. I can switch it back very easily with the one-line change. In this case, that one-line change is in code. I'll highlight that again right here. But we've done what our issue set out, so let's claim success. We'll stage our change. I believe this was 7. Let's double check that. Yep. And let's push our change. Okay, we've put the new branch up. We should be able to come here, take a look, and sure enough, I can bring the changes I made in the ag mean branch into main. So let's go ahead and create that pull request. No conflicts in the merge. It's exactly what we want. Continuous integration has kicked off. We can check its status. Okay, continuous integration has passed. Let's go back to our pull request. And let's bring that into main. All good. We'll not delete the branch this time, but it's a good thing if you do. And here we go. I'm all set. Let's stick to the script and create a new release. So this release is going to come off of main. It's going to be version 2.0.0. Now with the mean aggregator. So we'll run that workflow. It's been triggered. I can go check its status. We will repeat the CI process and then create and publish artifacts into the release. Okay, our release process has successfully completed. Let's go back and take a look, and sure enough, I now have release 2 created 11 seconds ago. And when I look at my releases, I can see release 1, this is, if you recall, has the sum aggregator, and release 2, this is using the mean aggregator. Each of those are tagged within the repository, so I'm feeling real good about that. I'm ready to go take credit for my work. So I'll close the item in my issue tracker. And that brings us to the conclusion of Act 2. Okay, Act 2 is done. Let's recap where we are. We have gone through all the initialization and setup. We've actually created something that meets the objectives of our number generator and aggregator. So our toy application is in place and working. We've managed to release version 1.0, a very simple MVP capability. We decided we wanted to put a more advanced capability in place with version 2.0. And so let's move on to Act 3. In Act 3, we're going to identify a critical bug. We're going to update the current release, and then we're going to update the past release. You can kind of see the path that we're heading down here as a spoiler. So here we go, on to Act 3. What is our critical bug? Let's go into issues. So our sample size, it turns out, in our number generator is too small. Analysis shows we need at least 1,000 samples from the number generator for valid results. Okay, stop the presses. We have got some functionality that dates back 2 releases that has a critical defect in it. What are we going to do about that? Well, the first thing we should do is fix it in the baseline, in the main baseline we're running right now. So let's go ahead and tackle that immediately. Let's get back to main. Let's make sure everything is up to date with a fetch and a pull. Success, outstanding. And let's go ahead and create a new branch. We'll call it 1,000 nums. So git checkout 1,000 nums changes our working branch. And now we're ready to really dive in and tackle this. So anytime we see a critical bug, the first thing we want to do is ask ourselves, how do we build the test to make sure that we identify this? And let's look at our number generator test. So what we're doing, we're making sure that we get no null value out of the generator. That's a good thing. But here's our size check. and it's only checking that we have at least one value. So let's change that to, based on this new requirement, at least 1,000 values. So there we go. I can, I'll be happy as long as I get 1,000 values and I have a test associated with it that will prove that point. Now, it's always good to make sure your test fails when you make one of these changes. So let's do a quick clean and a build. Thankfully, we have a failed assertion right here. Number generated failed, assertion error. What went wrong? Well, we can go look at a report. So our test is failing. That's exactly what we want. Now let's go make sure that we can fix the problem. So it's not an aggregator. Let's shut that down. It's not here. It's not in our aggregation tests. Clean all this up. And let's open up our generator. So here's our problem. We're generating 100 issues. We need to be generating at least 1,000. And because we like a little bit of margin as engineers, we'll just make it 1,500 to be safe. So there's our change. It's a very simple change. And let's see if that does it. Does our test pass now? We'll run our build. Everything executes and we pass. Our test is good. We've got the change, the fix made. We've done it in minutes. We're superstars. So how do we get this rolled into a baseline and into an updated release? So step one, we're going to, just like before, stage our change. We're going to commit that change. Let's make sure we know the number 11. We fix our numgen bug, and let's get that thing pushed up immediately. Push is complete. I'm good to go. Let's go back and check. I have a pull request just dying to be created. I'm good with all that. No merge conflicts. Outstanding. Configure continuous integration is going to kick off. We'll wait for that to complete. Okay, continuous integration has come back green. We're all set. We'll merge that and confirm. And success. The bug is fixed, but the bug is only fixed in our main branch. So let's first make sure that we get that out to our users. We're going to create 2.0.1. Number generator bug is fixed. That's going to trigger our release. And we'll come back in a moment and make sure that that completed successfully. And we'll see 2.0.1 here. So here's our problem. Let's say we have some users who didn't like the mean. They were happy with the sum aggregator. They're still on version 1, but the bug exists in their baseline. What are we going to do about that? So let's come back, and we need to do a little git foo to make this work. So let's check out our main branch. I do want to just monitor very quickly, let that release happen, and now it's done. So now I can do my git fetch. I can see the 2.0.1 tag has been incorporated. I'm going to do my git pull. I got my changes now on main. I'm good to go. So here's where things get interesting. I need to roll the clock back to my 1.0 baseline, and I need to make a change from my 2.01 baseline, transition into that. So how do I do that? First thing we want to do, let's create a branch. Okay, so I'm going to start by creating a branch. And we're going to call it release 1.0 maintenance. And we're going to build that branch from a tag in our history. So let's check. We now have that branch. Let's check it out. Okay, we're now in that branch. We'll do a git pull, make sure everything's up to date. Okay, we're set. Let's come back over here, just make sure. Yep, I've got my number aggregator. It's using sum. I've got my test. It's there. All well and good. Okay. So let's go find that last issue. Let's start, open up closed. Oh, actually, let's go open up the issue, and the commit that we made for that issue is right here. Number 11, fixed it. And here's a tag, an ID for that commit. I'm just going to copy that ID. And let's come back down here. We're going to do something called a cherry pick. I'm going to say cherry pick. I'm going to paste that ID in. And what it's doing is it's looking at the history of commits that we've made in this repository. It's finding that specific change, and it's actually applying it and committing it into this branch. So there's a change set associated with it. We'll open it up here. And let's look at the number generator now. Look at that. We didn't do anything. We just pulled that one delta change in, and we can see that we're now running at 1,500 numbers being generated, and our test has been updated to look for 1,000 values. So that change set has been brought back, put into this baseline, and is now sitting on this branch. That's exactly what we want. Let's just do good practice. Just clean everything up. Let's build and make sure that everything passes. We haven't broken anything. Outstanding. And let's push. All right, we have now pushed our change to our maintenance branch. It's going to let me do a pull request if I want to, but you know what? In this case, I don't want to. Let's go take a look at what's happened. So what's happened is, as we went through here, I actually took a branch off of the tag here, and I've created a release maintenance branch that has that fix to the bug in it. I can now come back here to my releases, and because I have that maintenance branch, I can select it and I can say I want release 1.0.1 to be generated from that branch. It's fixed my sampling bug. I'll create that release process. It'll go through my tests. And in just a few minutes, we'll check back. Okay, our release is completed. Let's come back here. I can see my latest release is now 1.0.1. I have 2.0.1 in place as well, so I can pull that forward, and my repositories are tagged. I can now pull off of those releases and make additional changes in the future if I want, and we can see what's happened. I've been working out of my main branch, AKA trunk, all along. But whenever I realized I had a bug to fix, I was able to pull that change down, create a release branch, a release maintenance branch, and get that in place. Okay, that's the end of Act 3. Thank you for sticking with me through all of that. We've gone through quite a bit, and thank you if you've stuck it out this far. Welcome to the end. But of course, like any good show, we want to take a look at the Encore. What's going to be, why would we do an Encore here? Well, we've created a situation where we now have concurrent development that we're just going to have to perpetuate. And that's a very costly and error-prone process, especially for something much more complex than my toy application. So the best case that we have is to really bring these back together in a meaningful way that's rigorously controlled, using the features that we've added in, the feature toggling in particular, to allow us to go forward and continuously support different target environments with different behaviors in a safe way. So here we are. I've cut Act 1 out, we got Act 2, Act 3, but here's our goal in the Encore. We want to get back to trunk. We want to kill that maintenance release branch because it's going to become an expensive and schedule consuming thing for us to deal with going forward. So we'll create version 3 here, and we're going to do a couple of things. First, we're going to externalize our feature toggles to configurations files, and we're going to deliver a release with configuration managed controlled execution scripts that we can take into ops. And what's great about that, you can deploy that with your Ansible playbooks. You can lock down the access and controls to make sure that nobody's monkeying with your config data that's specifically tailored to that target environment. And in the future, whenever you start delivering containers, even better, you can package these things up into immutable packages that you can run with absolute confidence that your configurations and your executable are correct. Okay, so here we go. How do we do this? Just like before, let's create ourselves an issue. Oh, we forgot to take credit for our work. So we're done and released on the bug. We'll close it out. And let's create a new issue. Let's say, get back to main. All right, we've got issue number 13 that we can now work to. Let's come back here. Let's get back to our main branch. So git checkout main. Make sure we're all up to date. We see the latest tag that was incorporated, and when we do our pull, we're already up to date. We're good to go there. So once again, git branch. Let's just call it Encore. And git checkout Encore. All right, great. We're in an environment now where we've got all of our latest changes in our baseline. We're working off of release 2.0.1, but we want to make a couple of changes to how we, not app test, but to how we actually control these toggles. And we're going to see that that's not terribly difficult. It will take me a little bit of coding to get it done, so I'll be back once that coding is complete. Okay, so the coding is done. We've made a few tweaks. We've turned our toggle into more of a name of our strategy. And we've created something called the properties. All this does is read a file and look at name value pairs. We read in an argument file. Now we could put error correction handling around this. Normally we should do that. But for this example, I think we're okay. And now what we're going to do is say if sum, which is the strategy that is identified here, is equal to the value that we get from our configuration, per that toggle name, then we're going to use a sum aggregator. Else, if mean is the property value that comes out, we're going to use a mean aggregator. And all we've done is created some very simple config files, a config directory, ag strategy is mean, and ag strategy equals sum. The other thing that we did that's useful is we created an executor. And since I'm just doing this as a simple Windows environment test, I just have my application that will run, and I'll pass in the mean configuration here. I'll pass in the sum configuration here. And all of this is controlled exquisitely within my configuration management repository as part of my release process. So we've externalized our feature toggle. It's now sitting in property file that we can run and point to. And we've created an execution context that lets us control how we run these things and target that to a specific environment. All right, great. Let's do a quick test to make sure everything's good. So Gradle clean. Gradle build. And this time, although I could have written automated tests to do this, I'm going to just go into my build, look at my distributions. Here's the app.zip that we actually release. So I'm going to extract that. And then I'm going to do a quick test to make sure that everything's as expected. So app, distributions, and app. So this is what's actually in our zip file that we release. You'll see 2 batch files there, and I'm just going to test them real quick. Run with sum. We got 1,500 numbers and a very large value, so that's looking as expected. And run with mean. We got 1,500 numbers and they sit around 50, so that is also as expected. Everything looks good here, so let's take credit for our work. Let's just get back up to the root of our repo. And let's just clean everything up just in case. And let's do a git add to stage our changes, git commit. That I have external feature changes. I forgot to put my tag in there. That'll come back to disappoint me later. But our changes are in place, so let's go ahead and just git push origin Encore. All right, everything is there. We'll come back to our repository and we'll see our Encore. We'll create a pull request. No merge conflicts, which is outstanding, just what we want to see. And let's let our continuous integration run. Okay, continuous integration has passed. We're happy with the changes. Let's go ahead and merge that pull request. Outstanding. We'll come back here. We'll take credit for our work. And let's go ahead and create that release. We're going to come off of main, and here we are. Let's call it release 3. It has meaningful new capability. Run that. All right, outstanding. Our release is complete. I can come back here, release 3.0, cmdemo.zip. Can download that guy. I'll extract it to here. Here's app. I wish. Let's do this. So let's test it. Run with mean. All good. Run with sum. All good. Outstanding. So now we have a release that we can target. It's fully configuration managed. My deployment or delivery mechanism is quite clear, what I would run and what I might want to choose to target in a given environment. And I can see my full history. And let's just take a quick look at what we've done. So here we have it. We've made a series of changes. We've been, with the minor exception, we've been using GitHub Flow to create small targeted branches. Those branches are associated with our change management tickets. And as soon as we get it done and working, we create a pull request and bring it back into our main branch. As appropriate, we choose to make releases. We've automated the release process. It has our quality checks in there, and it tags everything as it's built out. In the worst case scenario, if we find some issue and we need to go back, we can always create a branch off of that tag and make a targeted fix, or better yet, make a fix in our main branch and then cherry pick that over to our maintenance branch. But we don't like maintenance branches. They are expensive to keep up with, and they often create lag and diminish our responsiveness. So with affordability in mind, we want to make a change that allows us to target specific configurations to specific target environments with specific enabled behavior that we can simply maintain in a single baseline. This allows us to make much more straightforward choices when we see errors and quality issues. We can make them, and as long as we keep our test baseline, not only our unit test baseline, but our acceptance test baseline up to date, we're in pretty good shape. And we should have confidence in that release. So we are at the end. I want to thank you for walking through this with me. This is a little bit different than what we've done in the past. I hope you find it valuable, and I hope you can join us for our regularly scheduled meetup on the first Thursday of every month. Please stay safe out there and have a great holiday season.